Section 2.5 is a lot like Section 1.5 in that it's a word problem section and we do some businessy word problems. And before I jump into the word problems, we just need to know some basic formulas. For those of you that are business majors, these should be familiar formulas. And even if you're not a business major, they're not particularly complex formulas. So the first formula that we're going to need is profit is revenue minus cost. Basically, for a generic business, the sales less their expenses is going to be their profit. How much money you take in less how much money you spend, that's going to be your profit. So this formula is going to be important. We also talked about marginal profit in the section 2.5, and it comes back again in this section. Also in this section, we're going to go deeper into marginal cost and marginal revenue, but not that deep. And this right here, I lifted from section 1.5. Marginal profit is the profit earned by selling one more unit. I think I said, like, if Apple sells, they normally sell 1 million of a certain iPhones and they sell 1 million and then one iPhone, that extra profit that they make by selling that iPhone would be the marginal profit for the millionth and first iPhone. Maybe they make $400 in profit, the difference between what they sell it for and what it costs them to make it. So the marginal profit, it's not the gross profit, it's just the profit by selling one more unit of whatever product that we're selling. And the marginal profit function is just the derivative of a profit function. Marginal profit's the difference between marginal revenue and marginal cost, because profit itself is revenue minus cost, so marginal profit is marginal revenue minus marginal cost. And that's what I wrote there. And then marginal profit analysis, it's a big deal in business because if the marginal profit is positive, then it pays to make more and try to sell more. If the marginal profit for the next item sold is negative, well, then you shouldn't try to sell more because you're losing money on every product that you sell. And then under marginal analysis, the optimal production and sales level is when marginal revenue equals marginal cost, and that's when marginal profit is 0. Because if you look at this, for marginal profit to be 0, that means, because marginal profit is marginal revenue minus marginal cost, that means if marginal profit is 0, that means marginal revenue minus marginal cost, I don't know if I could fit this here, equals 0. And if I add marginal cost to both sides of the equation, I can't barely read that, you get marginal revenue, I'm just going to write MR, equals marginal cost. So just if marginal profit is 0, because marginal profit is marginal revenue minus marginal cost, if you take this equation and solve it for marginal revenue by adding marginal cost to both sides, you get marginal profit as 0 when marginal revenue equals marginal cost. When the amount of money you get for selling, extra money you get for selling a product is the same as the cost. Marginal cost is similar to marginal profit. Marginal profit's the profit when you sell one more item. Marginal cost is the additional cost of producing one more item of whatever product you're selling. In our class, most of the business examples are dealing with a company just selling a single product. If we start getting into multiple products, the algebra and the calculus gets way too complicated. So for the problems in this section, we're going to have small companies doing single product sales to keep the calculus, tolerable. And marginal revenue is the extra revenue by selling one more item. Marginal profit's the derivative of a profit function. Marginal cost is the derivative of a cost function or cost formula. Marginal revenue is the derivative of a revenue function or revenue formula. Marginal kind of implies derivative in some sense, and it implies next. Marginal profit, derivative of the profit function. The extra money you make, extra profit you make by selling one more item. Marginal cost, derivative of the cost function, the additional cost to produce and sell one more item. marginal revenue, derivative of the revenue function, the additional revenue by selling one more item. So this is a super standard example here. Here's a marginal profit example. So a corporation makes a single product. The whole single product is a semi-big deal to make the algebras tolerable. And it has a weekly profit function by selling X units. So this function basically says the weekly profit from selling X units is given by this basic formula. This formula probably would have nothing to do with reality, just makes the algebra easy. So first it says find P of 80. That's just plugging 80 into the profit function. So P of 80, P means profit, 80 means 80 units of this product. The profit from selling 80 units of this product is negative 0.1 times 80 squared plus 20 times 80 minus 36. So first I'm going to get the number, then I'm going to write what it means. So the number is going to be negative 0.1 times 80 squared. The 80 represents 80 units of this product, plus 20 times 80 minus 36. And the answer I get is 924, the numerical answer. So the answer to part A, P of 80 is 924. When I plug a value of X into a profit function for this particular company, that X represents the number of units of the product that are being sold, and the number that I get out is the weekly profit. So when I went to do part B, interpret your answer, didn't need to round to 2 decimals because it wasn't applicable, but the weekly profit will be $924 in the week when 80 units are sold. So plugging money into plugging an X into a profit function gives you the profit for this period of time, in this case per week. Now I'm going to do part C, create the marginal profit function. Well, the marginal profit function is just the derivative of my profit function. And I can do the basic power rule for this derivative. So I'm going to take the exponent 2, multiply it by the coefficient of negative 0.01, lower the exponent of the x squared to x to the first. The derivative of 20x is just 20. The derivative of minus 36 is 0. If I multiply the 2 times the negative 0.1, I get the marginal profit function, which is going to be negative 0.2 times x plus 20. And this should say the marginal profit. So my marginal profit function is negative 0.2x plus 20. Part C wants me to plug 80 into the function. So for part C, so this was A, this was B. Part C wants me to take that function and plug 80 in. That represents 80 units. And what I'm going to get out is not the total profit from selling 80 units. I already know that. When I plug a number into the marginal profit function, I get the extra profit by selling one more unit. So this is going to be 4 for the answer to part C, because when I plug it in, I get 4. So when I wrote my answers down here, I said P prime of 80 is 4. And now interpret my answer. Well, when I plug a number into the marginal profit function, it doesn't give me the total profit. The total profit for selling 80 units is $924. It gives me the additional profit that I could earn by selling one more unit. And so an additional $4 of profit will be earned by producing and selling the 81st unit. So marginal kind of means next. It's not gross and total. Let's do the same thing with the marginal cost. So I have a cost function for producing X units of a product. And this doesn't give me a time frame, but it basically says if I make X units of a product, it's going to cost me so much money. Part A says plug 10 into the cost function just to get us understanding what the cost function for this particular product is working like. So I plug in 10 for the X's. And when I plug in 10 for the X's, I'm going to need to use my calculator. And what I'm going to get out is the total cost to produce 10 units. So if I do negative 0.04 times 10 squared plus 80 times 10 plus 2350, I get $3,146 for my answer to part A. So that's just a number without any words attached to it. Part B wants me to attach some words. This is a cost function. Putting 10 in for the cost functions means 10 units. What I get out when I plug a number into a cost function is a total cost to produce that many units. So I said the total cost to produce 10 units is $3,146. The 10 being the number in the parentheses, the 3146 get the number my algebra gave me. Now I'm going to do part C, create the marginal cost function by taking the derivative of the cost function. So marginal implies derivative. To do this derivative, I'm going to multiply the 2 times the negative 0.04. I'm going to lower the x squared down to an x to the first. The derivative of 80x is going to be 80. The derivative of 2350 is going to be 0 because it's a constant. And so I'm going to get the marginal profit function. When I multiply these, I get negative 0.08 times x plus 80. That's going to be my answer to part C. The marginal cost function is negative 0.08 times 80. Part D just wants me to plug 10 into the marginal cost function. I don't have the little prime there, but it should be there. So for D, I'm going to find the marginal cost function evaluated at 10 by going negative 0.08 times 10 plus 80. It's going to give me a number that I'm going to need to interpret that number. So negative 0.08 times 10 plus 80. This gives me 79.20. So my answer to part D is 79.2. And if I interpret, so the marginal cost gives me the cost of, not the total cost of producing 10. The total cost of producing 10 of whatever these are is $3,146. It gives me the cost of producing one more item, and that one more item would be the 11th unit. So this $79.20 represents the cost of $79.20 to produce the 11th unit of whatever product this is. That isn't new. What is going to be new to us, but maybe not new in general, is a price demand function. So basically, for most products, the higher the price, the less gets sold. The lower the price, the more gets sold. And there's a relationship between the price and the number of units of a product sold. And mathematicians or statisticians, economists could come up with functions that can predict. If you tell me what the price of the item is going to be, I can predict how many you're going to sell. Conversely, if you tell me how many you want to sell, I can tell you what I need the price to be. This is what the price demand function is. If you tell me how many you want to sell, I can tell you what the price needs to be. So a price demand function, of course, demand depends on the price of the product. The higher the price, usually the lower the demand, but not for everything. Some really, designer products, maybe if they charge way more money, they will sell more because it appeals to somebody that it wouldn't appeal to, and maybe at a certain price nobody will buy it. But in general, the demand depends on the price. The more the price, the less the demand. The lower the price, the more the demand. And that's what I just wrote here. Generally, lower the price, the more people will want. The higher the price, the less people will want. A price demand function just describes a relationship between the number of units demanded and the price. So symbolically in this, the X represents the number of units that are going to be demanded for that particular product, or the number of units that somebody's going to want to buy. But demanded feels like a good business word here. And when I plug the X into this function, I'll get the price that will cause that many units to be sold. Cause the demand to be that many units. So in a price demand function, I'm going to plug in a number of units and I'll get out the price that it will take to sell that many units. So here's just a simple price demand function for some generic product. So here's a simple price demand function where X represents the number of units of a single product that are sold, and P of X is the price to sell that many units of the product. Let us evaluate the function at 20 and explain what it means. So I'm just going to take 20 and plug it in for that X. It says the price to sell 20 units is negative 1.25 times 20 plus 50. I did this on my calculator. The price to sell 20 units is going to be 25 bucks. This is how I read my price demand function, because the P stands for the price, the X stands for the number of units. So the price P to sell 20 units is $25. Here I have a lowercase p, and in a profit function I have an uppercase P. It's kind of unfortunate that price and profit start with the same letter, and the price demand function and the profit function both have P's. Profit functions generally have an uppercase P. Price demand functions usually have a lowercase p. So when I plugged 20 in, the 20 represent the number of units of the product sold, and the 25 represents the $25 that will cost, that the price that will make 20 units get sold. So I just wrote this up. I said the algebra basically tells us that at a price of $25, 20 units will be sold. So I give you the number of units that will want to be sold. I can get out the corresponding price. I could create a price demand function that does the backwards. You give me the price and I give you the number of units. But for our class, this is the kind of price demand function we're going to use, where X is the number of units and P of X is the price. Price demand functions are used to create revenue functions. In a company that sells just a single product, the amount of revenue they're going to generate, their sales, is going to be the price of the item times how many they sell. If I'm just selling, sweatshirts for some school raffle, for some school club, and I sell the sweatshirts at $40 each, $40 would be the price. If I sold 10 sweatshirts at $40 each, $40 times 10 sweatshirts would be the $400 in revenue I'd get from selling those sweatshirts. So revenue, when a company is producing a single product, the amount of money that they're going to get, not profit, but just the revenue, how much sales they're going to have, is the price of the product times the quantity. For this last example, the revenue would be the $25 that will yield 20 units of sale. $25 per product times 20 products gives me $500. So for this particular company, $500 of revenue will be generated when 20 units are sold for $25 each. I can use the price demand function to create a revenue function. This didn't seem obvious to me when I was a student. It almost didn't seem legal. It didn't seem right. But how do I do this? It's so easy. A revenue function I usually write with a capital R of X. Revenue function is price times quantity, and quantity I'm going to make X. We'd like the price to be P, but then I wouldn't get multiple variables. For the price, I'm going to use the price demand function. And the price demand function for this was negative 1.25x plus 50. So revenue is price times quantity. Price is the right-hand side of the price demand function. The quantity is X. So a revenue function for this particular product is the price function, the price demand function, which is the function that generates price based on a quantity, times the quantity X. And so my revenue function, if I simplify this, is going to be negative 1.25x squared plus 50x. So for this exact same product that had this price demand function, this is the revenue function. Well, look what I could do with the revenue function. I could plug a number into the revenue function and get the total revenue from selling that many units. I already know that if I sell 20 units, I'm going to get $500 in revenue, because to sell 20 units, the price has to be $25. Here, I can do this computation directly. If I take a number and plug it into the revenue function, That number represents the number of units of the product. So this says the revenue for selling 20 units of the product, the same product that I've been doing for this example, is going to be negative 1.25 times 20 squared plus 50 times 20. Well, I know for this product in this price demand function, to sell 20 units, I need to charge $25 each, and the revenue is $500. That's going to tell me it right here. When I do this on my calculator and do negative 1.25 times 20 squared plus 50 times 20, I get $500, which is exactly what I did in a backwards way here. So this says when I sell 20 units, I'm going to get $500 of revenue. It inherently calculates the price without telling me the price, doing it this way. So this is the same answer to part B because it's just another way of asking the same question. I get a little less information because I don't get the corresponding price that I did in the other way. Let's do a marginal revenue full out example now. And work with this price demand function to understand it better. So I have a price demand function that for this particular product, the price demand function P of X, which is the price to sell X units of a certain product. So the P of X is the price to sell X units. X is the number of units of a single product. This is the price demand functions. X is the number of units of the products that's going to be demanded. And P is the price that corresponds, or P of X is the price that corresponds to that many units. First it says find P of 10. So for part A, I'm simply going to use the lowercase p, which is my price demand function, and plug in 10. And this is going to give me negative 1.50 times 10 plus 75. So negative 1.50 times 10 plus 75, I get 60. So the answer to part A is P of 10 equals 60. Now I need to interpret. Well, the 10 stands for the number of units that we want to sell. The 60 stands for the dollars. So for part B, something like this. How about this? 10 units of the product. The 10 is the number of units of the product. 10 units of the product will be sold. And the answer to part A is the price that gives you that. When the price is 60 bucks. So plugging a number into a price demand function, the X is the number of units, the corresponding number that you get out is the price. Now I'm going to create the revenue function in part C. Revenue is price times quantity. And for us, I'm going to use the price demand function for the price. So my revenue function is going to be the price demand function. This is the price of the object for X units times the quantity, which is going to be X. When I clear this parentheses, I'm going to get the revenue function, R of X, equals to negative 1.50, and then X times X is X squared, so X squared, and then plus 75X. That's the total revenue for selling how many ever units of the product. Part D wants me to find R of 10, so I'm just going to do the total revenue for selling 10 units of the product as negative 1.50 times 10 squared plus 75 times 10. So negative 1.50 times 10 squared plus 75 times 10. The number answer is 600. For part D, the number is 600. When I plug a number into a revenue function, I get the total revenue for selling that many products. So for part D, to interpret my answer, I might say a total of $600 of revenue will be earned by selling, or when 10 units were sold, by selling 10 units of whatever this product is. Now I'm going to move on to part F and find the derivative of the revenue function, which is the marginal revenue function. So I'm going to take the function, the revenue function, which is negative 1.50 x squared plus 75x, and I'm going to take its derivative. I'm going to use the power rule and go 2 times negative 1.5. I'm going to write my derivative symbol. 2 times negative 1.5 is negative 3.0, and then times x, so lower the exponent by 1. The derivative of 75x is just 75. So this is the marginal revenue function. The answer to part F, the marginal revenue function, is negative 3x plus 75. I'm trying to make the numbers really easy to work with, which makes the, well, maybe not so, everything maybe doesn't really fit with reality, but we need good numbers. Part G just wants me to plug 10 into the marginal revenue function. So I'm going to do marginal revenue function devaluated at 10 is negative 3 times 10 plus 75. And I can do that without my calculator. That's negative 30 plus 75, which is 45. And now I need to interpret. For part H, to interpret my answer, the marginal revenue is not the total revenue. The total revenue to sell 10 items is $600. This is the additional revenue by selling one more, or the 11th product. So I might say an additional $45. That 45 is $1, and it's dollars of revenue will be generated or earned maybe by selling the next item. In this case, the next item is going to be the 11th item. By selling the number in the parentheses, I need to increment up by 1. So selling the 11th item. Now I think we're ready to do some of the homework problems. That's all the theory that we need. So let me break this into a part 2, and in the part 2 I'll do the homework. And it's just a bunch of word problems that are just going to be repeats of what we've done, other than maybe I'll have to create a profit function. I forget if I snuck that in there.